And I would like to welcome everyone once again. Thank you for joining today. As Yingjun have said, we have been working hard on Iceberg integrations over the last couple of months and over the last couple of releases. And today is the day to make these things more public and to discuss these things. So as you have known, like we have been invested quite a lot of our efforts into integration with Apache Iceberg. That definitely made triumphant in this open table formats battle. And we'll continue to do so. And Yingjun will explain why, and will explain what are the key integrations and what's the rationale behind those. And we focus, because of the limitation of the time, we focus on the last couple of releases, but you can always check our website, our docs to see what's there. So thank you, Yingjun, once again. The floor is yours.
Yeah, all right, thank you. Yeah, first of all, thanks everyone for joining the webinar. And it's early in the morning in the Bay Area, but I know that for definitely Iceberg is a very popular topic, and everyone is just discussing that. And essentially, as Giovanna mentioned, we have already worked on the Iceberg for a pretty long time. Actually, a pretty long time. I think we're probably over um, almost 3 years. But over the last few months, we actually did a lot of implementation works around the Iceberg. And today I just want to present to you what we have and what's the best way to interact with Iceberg, how do you read and write Iceberg using RisingWave engine. So yeah, just one single slide about myself. I mean, I'm the founder of RisingWave, and prior to that, I was at AWS Redshift. And AWS Redshift nowadays will also have their own Iceberg engine. So it's probably not called for their own Iceberg engine, but we have the capability to access the Iceberg. And so RisingWave itself is more like well, I mean, from day one, it's a streaming database, right? So essentially, before diving deep into Iceberg, I would like to introduce something about our journey, yeah, over the last 4 years or even 5 years. So, if you started, yeah, paying attention to RisingWave project, you will know that, well, essentially before 2024, it was focused on we promote it as like a stream processing system, or probably something like a streaming database, right? And we were pretty much focused on streaming ingestion, stream processing, streaming analytics, streaming ETL, streaming whatever, right? And that's pretty cool, right? When basically it allows people to ingest the data from the Kafka, Postgres CDC, probably S3, and do processing. And after that, we send the data out to some other systems that directly serve the online applications. Well, in 2024 and 2025, we believe that, well, okay, we have already done really, yeah, a good job we believe that's why it's a pretty good job in stream processing. And we actually started working on the improving our serving layer, which means that we allow people to focus, use RisingWave to serve serve a low latency queries. So in the past, what people probably used was something like, okay, probably Flink plus Redis, or probably some Spark streaming plus, well, let's say DynamoDB, right? But what in our vision is that well, you actually should not use so many systems because of all this kind of complexity, because of all these kind of consistency issues, right? You probably just want to use a single system to do everything. And essentially, that's why we were pretty much focused on low latency serving over the last 2 years. And nowadays, well, you could essentially use RisingWave as a key value store to some extent to serve low latency query. And if the requirement is like, okay, 10 millisecond latency, I mean, a key value store access, KV access, the RisingWave is definitely capable of doing that. So yeah, there's no issue with that capability. Well, in starting from 2025, we actually invest more resources into the Iceberg integrations and also something we call the managed by Iceberg. And today, if you check our website documentation, you will see this figure, right? Instead of just being like, okay, in just doing something like stream ingestion, stream processing, low latency serving, we actually use raw Iceberg to serve to manage the data internally as the column store. I mean, in RisingWave, you essentially have two kinds. You can have the option to have two different stores. One is the keyword store, I mean row-based store, and the other one is the column store. And the column store is essentially powered by the Iceberg installed in Iceberg format. So that's where you can essentially use your any query engine to access the column store managed by RisingWave. So that's our vision, right? So we started from a stream processing, focus on basically low latency stream processing to streaming, yeah, keyword store serving, KV serving, right? And nowadays, well, we are pretty much focused on Iceberg integration and managed by Iceberg. So why Iceberg? Well, I mean, this webinar is all about Iceberg, right? So I don't really think that's where I should spend time educating people. Okay, why Iceberg? Because for nowadays, well, I have to say that for every company starts to talk about Iceberg. So I know that's what a lot of companies probably just are talking, and they think that okay, I probably yeah, I still don't really know how to use Iceberg. Or actually probably I do have the use case, but it seems that for Iceberg probably I don't really know Iceberg whether was a good fit, right? So I know that's what a lot of people are just exploring. That's fine. But if you look at the market, who actually have the managed Iceberg service? So essentially, all the vendors listed in this page have the managed Iceberg service. So you can essentially directly adopt the Iceberg table, hosted Iceberg from these vendors, right? Including Snowflake, Databricks. Well, I think where Databricks it was still at the early stage. I mean, they have their managed Iceberg table was not GA yet. For it was still under private preview, and RisingWave itself is essentially a Databricks partner regarding the Iceberg project. And we also see that for AWS and the GCP also have the managed Iceberg. In AWS, it is called for the S3 table, while in Google Cloud, it is actually called the BigQuery Iceberg managed, yeah, BigQuery managed Iceberg, yeah, something like that. And Cloudflare also have their Iceberg table. And inside the RisingWave, we essentially also provide the managed Iceberg. So forget about how to manage the something like catalog, forget about how to manage compaction. All these vendors can do everything for you. So that's why it basically help you to lower the bar to explore Iceberg, right? Okay. And then let's talk about something about yeah, RisingWave and Iceberg. So what can RisingWave do with Iceberg, right? For any system, well, basically there are two operations. One is to read, and the other one is to write, right? We can definitely read from Iceberg, and RisingWave can nowadays, well, in the current version 2.5, it can read from Iceberg, and it could also write data into Iceberg. But the thing here, that's how we interact with Iceberg, right? Well, is it like, okay, more like an external table or something like, I don't know, internal table? Well, in which way we should interact with Iceberg? Well, we feel that people actually have different needs. And some people actually have already have their own internal Iceberg and have already had their internal systems building the systems accessing Iceberg. Well, some other people may be more like open to, let's say, more at an exploration phase, and they just want to use Iceberg directly. So essentially, we provide the two ways for people to access Iceberg. One is called, well, we call it, well, I mean, the pipeline way, which means that, well, you could essentially interact with Iceberg as the source and sink. just like a pipeline, right? Well, in any pipeline, no matter whether it's RisingWave or no matter whether it's Spark, we have the source and sink. We can ingest the data from source and then do some transformation, and then probably optionally do some transformation, and then send the derived data into downstreaming systems. That's a pipeline way. And the RisingWave could essentially interact with Iceberg using this way. Well, but for some other people just say that, well, okay, I just want to use Iceberg as a table, right? Well, as a regular table. How do I do that? In RisingWave, in this case, will also support what we call it a database way to interact with the Iceberg, and I will show you later. So let's talk about the pipeline way first. So in the pipeline way, as I mentioned, well, people can want to probably ingest some data from the upstream systems. And optionally, they do some transformation and then send the data into downstreaming systems. In RisingWave, you could essentially use Iceberg as both source and sink, right? Well, when using Iceberg as a source, it means that, well, you can essentially ingest the data directly from Iceberg in a streaming way. Meaning that, well, you do not need to use any orchestration tools to batch load data probably every single day, probably every single night from the Iceberg. It's in RisingWave, it's all about the streaming way to ingest the data from Iceberg. And then in the meanwhile, you could also sync the data into Iceberg. We see many people actually ingest the data from Kafka or probably from Postgres, and they do something like joins, right? Well, imagine that's where we have the in an e-commerce use case, we probably want to join the order data as long as along with the order data as along with the user data, right? And if you want to do such kind of enrichment, well, RisingWave is definitely a very good option. And after enrichment, well, you could directly send the data into Iceberg. Or probably if you want to send the data back to Kafka for sure, yeah, let's do that. So you can definitely do that. And okay, then I want to show you how you could use RisingWave to directly ingest the data from Iceberg. And we just want to focus on, in RisingWave, from day one, we just want to focus on the simplicity. Well, we want just to focus on the user experience. We just want to make sure that users could have a super easy way to do streaming, right? Or to do data streaming, to do stream processing. And same here, if you want to ingest the data from Iceberg, the only thing you want to do is to connect to an Iceberg table. Here, I just showed you a table, right? Well, matched by, I don't know, you can, it's stored in S3, right? And you basically just need to, and this is the REST catalog, right? You can see that, well, this is the REST catalog. If you're not familiar with REST catalog, basically REST catalog is a specification, and it actually defines how you could interact with Iceberg. And in the open source world, you could choose Apache Polaris, or probably could choose the Lakekeeper, and also in Databricks, where you could also choose Unity catalog. So in order to ingest the data from Iceberg, the only thing you need to do is to tell people, tell RisingWave where the data is, right? You can just tell us, tell RisingWave that. Well, you can use the statement create source, right? And tell RisingWave, okay, this is Iceberg, and where the data is, and where my catalog is, right? Basically, that's what the only thing you need to tell RisingWave, right? But definitely you also have to tell us, okay, the S3 key, right? S3 key will be managed in the security store, so you will never need to worry about the security. Security. So once you connect RisingWave to your Iceberg table, then you can essentially do do everything, right? For example, you can directly do the batch query, right? And to select everything from the Iceberg where the event date is larger than some date, right? And in the aggregation, you can also do all these kind of aggregations, right? So there's one question. Do you think Iceberg is good fit for raw event data with huge volumes? For example, as event with 10 terabytes per day per table, the table might have thousands of columns. So look, we do have actually a bunch of customers for in the e-commerce space, and one of them is pretty big. Yeah, e-commerce website, pretty big e-commerce website. I'm not sure whether they have 10 terabytes per day. They didn't really show us with the data volume. But what I know is that they actually, as mentioned, essentially they join the order data with as long as along with the user data, and sometimes they also need to join the order detail data. So it's Iceberg is essentially good enough. I have to say that's why it's good enough to manage the to manage huge volumes. Actually, it's way better solution than any than just storing data as the raw per query file. Because well, if your data volume is large, well, you probably need to worry about the schema evolution. You probably need to worry about the something like okay the compaction or something or small files, right? But well, in Iceberg context, well, it basically handles everything for you. So that's why it's definitely I believe that's why I mean it's definitely a good fit. Um, yeah. The only thing you probably need to worry about is that well, how frequent you want to write into Iceberg, and we do have some first-hand experiences, and I will share it later. Okay. And there's another question. RisingWave has the option to store its data in raw format or in Iceberg format. Yes, that's true. Under which circumstances Iceberg the suitable option? So basically, we have two options because for in some cases, well, people don't really people just want to directly serve their application, right? In this case, well, they actually want to use they actually want to use the row store. Think about Redis, think about something like DynamoDB or probably yeah, what is called for the Cassandra, right? You probably don't really want to manage another system, yeah, for performance issue, consistency issue, or probably cost issue, right? And writing with Rostore is good enough to serve the key value access. And one thing I want to highlight is that RisingWave actually store data in S3, store persistent data in S3, and caches data in local disk and memory. So first thing, it means two things. The first one is that storing data is really cheap because we essentially compress the data in S3 and for the cool data, right? Well, let's say imagine that you have a huge amount of data like yeah, like order data or order book data, right? You probably have huge amount of data. In the writing wave case, well, it actually even if it is stored in raw format, it actually will compress the data, right? And in the meanwhile, you do not need to worry about the latency because we actually use the memory and the local EC2 memory and as well as the disk to cache the data. So the memory could be 10 millisecond, 20 millisecond. I'm talking about P99. P99, for P99, 20 millisecond is yeah, it's definitely achievable. For 10 milliseconds, I have to say that okay, definitely there probably we have to work on the tuning because you probably need to if you have a huge amount of data, you probably need to think about okay, which data I want to put in the cache, right? Or the other way is actually you can basically put everything in the cache for sure, that's definitely a feasible way, but well, definitely it will incur more cost. Think about well, it's basically the same as well managing everything in Redis, which could be expensive, right? Yeah. Um. Yeah. So yeah, thanks for these questions. Okay, that's about well, how we can ingest the data from Iceberg, and then the other very interesting operation you can do is to create a material views on top of Iceberg, right? If you look at the Iceberg, Iceberg specs, you'll notice that Iceberg doesn't really support index. It doesn't really support material views. Talk about the official spec. But in RisingWave, you could essentially create a materialized use, incremental materialized use directly on top of Iceberg. So how do you do that? So basically, after create a source, after connecting a RisingWave to your Iceberg table, right? We're using this statement, create a source, REST Iceberg source. You could basically directly create a materialized view on top of Iceberg. And notice that the iceberg is the material view is automatically refreshed. So you do not need to, but if you use something like Redshift or some other systems, you probably have to manually trigger the refresh, right? In RisingWave, we can always guarantee that the data is up to date. The result is up to date. Well, I'm talking about the material view result. It's always up to date. And also, I want to mention that you could also do all these kind of like complex operations. For example, one thing I noticed that which is super popular is that people want to combine the Iceberg data with a real-time data stream, right? Imagine that I have let's say I'm running a let's say e-commerce website. And there are probably some user behavior events, right? People probably click some button, right? And I want to join this event along with my Iceberg table, right? With the user information table. I want to do this. How do I do that? In some other systems, you probably need to hand code the right hand code the logic, and I don't know how you probably and access the Iceberg table using probably JDBC or some other protocols. But in RisingWave, the only thing you need to do is to create a material view, and you can just in the material view you can define that okay, I want to join the source, Iceberg source along with my probably a Kafka topic. For sure, you can do that. So that's something we can do within RisingWave. But if you look at many other systems, you will notice that their materialized view, they probably have materialized views, but their materialized view is probably not doesn't really support for accessing handling joins. Yeah, that's something we have in RisingWave. Then let's talk about writing to data into Iceberg. So in RisingWave, it's pretty simple. I probably don't really want to waste so much time on this topic. But it's super simple. The only thing you need to do is to create the sink, right? Imagine that where you have two Kafka data streams. All you want to join your Kafka along with your let's say Postgres CDC stream, CDC, right? After joining these two data streams, the only thing you need to do is to create a sink, right? Create a sink, REST sink from my data. My data could be like some materialized views or some other tables, and tell us okay where the data looks like, where the iceberg is, right? So that's pretty simple. That's just just as simple as creating probably a Kafka sink or any other sink. Yeah. So that's how we interact with Iceberg as source and sink. And then let's talk about for the interacting Iceberg as the tables, the database way to interact with table. So if you're from the data warehouse world, right? So I came from Redshift, and in Redshift everything is like a table, right? And I can probably just mount an external table and then use Redshift to query the data in there, right? And we know that's where this is definitely popular. And RisingWave also today we also support this functionality. That is, so we allow people to read and write Iceberg tables just like an internal table. How do we do this? It's pretty simple. The only thing you need to do is that so instead of telling us what the Iceberg table is, right? So you tell us where the catalog is. You can just use this statement, create a connection, public.com, with and tell us, okay, where your Iceberg catalog is, right? Once we get access to your catalog, we know, okay, what the data looks like, what the data type looks like, what the table you have, and then you can do everything you want right? And for example, you can probably just insert data into Iceberg. Just using this is something I want to highlight. Well, I mean, you can using RisingWave, you could essentially consider Iceberg table as the Postgres database, and the RisingWave could essentially allow you to insert data, query data, create material issues, uh, from and to Iceberg just using Postgres way, because for RisingWave is Postgres compatible, and you can directly use pSQL to connect to your Iceberg and do all these kind of operations. Um, okay. Um, okay. There are a lot. Okay, so there's a bunch of questions. Um, how is RisingWave handle Iceberg schema evolution? Yes, that's something we want to mention. I'm assuming it's inferred from the source data. Is any support provided to modify the schema at the runtime? So yeah, definitely that's a very interesting question. I actually will cover that part later about the schema evolution. Essentially, look, well, how we change the schema. The thing we typically the why we want to change the schema. Typically, it's mainly because for the upstream systems actually change the schema, right? Imagine that you want to ingest your let's say data from, let's say, from Kafka, and then replicate the data into Iceberg. That's right. Definitely, that's basically a very standard ELT, right? And in this case, we do actually essentially extract the Iceberg so Postgres for the schema, and we actually know when the Postgres will changes a schema, and we actually propagate this change to the downstreaming system, no matter where it's Snowflake and or no matter where it's Redshift, or no matter where it's like Iceberg. But the one thing I want to mention that for the schema evolution in Iceberg, it will be available in 2.6 instead of 2.5 because we're still under testing. So yeah, so in 2.6 you should be able to directly do schema evolution with the Iceberg Stink. Yeah. Okay, so let's go back to the how we interact with Iceberg as tables. You can essentially just connect to your Iceberg catalog and do everything. And one thing I probably didn't really mention here is that you could also create an Iceberg table. Um, yeah, it seems that's why I missed that query. But the only thing you need to do is to create a table, and tell us that the engine equal to Iceberg. Using this statement, you could directly create a table inside of Iceberg, right? Um, so yeah, there's another example. Well, for example, sorry, there's another query. For example, I'm running an ads campaign and see average order size for window last fit. Yeah, yeah, for sure. Yeah, window functions for sure. Yeah, time window. Yeah, yeah. Well, no matter what kind of window function you want, well, definitely, it's pretty standard. Yeah, pretty very standard and a pretty common pattern. And for Windows, well, definitely it's pretty powerful, powerful function. For example, if you are in e-commerce, well, as this question mentions, well, I mean, you probably want to do something like, okay, average order size, right? And the more popular thing we found is that, well, in the trading world, people actually care about, okay, what's the average price over the last 5 seconds, over the last 10 seconds, over the last 1 minute, over the last probably 30 minutes, right? If you open your Robinhood app, or probably open your any trading terminal, you will see this kind of thing, right? And essentially, RisingWave powers a lot of these kind of applications in real world. Yeah. And okay, so as I mentioned, well, some people were probably just new to Iceberg, and they have no idea about, well, how to host the Iceberg, right? Well, how to host the Iceberg table and sorry, catalog, right? So no worries. Well, if that's the case, well, you could the only thing the in RisingWave, we actually could help you to host your Iceberg catalog, which means that you do not need to download anything from any website. How to do that? RisingWave actually have this unhosted Iceberg catalog. And the only thing you need to do is to tell us that is the hosted catalog. So basically set this parameter to true, and you will get the hosted Iceberg immediately. So there were some limitations at the moment in 2.5, but 2 weeks later, in 2.6, we will have a better version, which allows you to essentially to switch the catalog type. Because we know that in Iceberg it has all different catalogs, right? You have JDBC catalog, you have REST catalog, and in REST catalog you also have different implementations, right? What if I want to just have, let's say, JDBC catalog, and what if I want to have, let's say, REST catalog, right? So we understand that. And in 2.6, we will allow you to actually change the catalog. At the moment, if you use RisingWave's hosted Iceberg catalog, it's essentially a JDBC catalog. Basically, it's basically powered by Postgres. And you could directly use engines like Spark, Trino, some others to directly access what the basically the query engines who could that can access what the REST catalog, the JDBC catalog. You can use any engine to access the RisingWave table. Yeah, but from the next version, so basically it's more about the deployment, mode, and we will allow people to basically switch the Iceberg type. You can probably use, Polaris. I don't know. I'll probably use Lakekeeper. I'll probably use some other catalog services. We will allow you to do that. So what's the main issue of managing Iceberg? People will always say that, well, small file problems, right? It's definitely a valid problem because we're in Iceberg. Was initially designed for batch processing. So if you ask me, okay, whether if I have 10 terabytes of data, 10 terabytes data generated every single day, is it suitable can we use Iceberg? The answer is definitely yes, because if you check the initial proposals of Iceberg, it's basically designed for managing petabytes of data or even hundreds of petabytes of data. So definitely that's not an issue. And but in the meanwhile, so Iceberg is not totally bad for the streaming ingestion. And it's really, really bad at supporting frequent writes. And I will discuss more about that. The reason here that Iceberg under the hood is basically a bunch of Parquet files, right? So Iceberg is, you could imagine that it's a singularity of Parquet files. And for Parquet files, if you continuously write data into Iceberg, essentially you will generate a bunch of Parquet files, right? And let's say that for every single Parquet file, imagine that if it's just, let's say, 1 kilobyte. It's too small. And accessing S3 frequently will cause huge amount of cost, right? Because it was actually charges you based on the number of access, right? And also you should know that S3 access is slow. So having so many small files is definitely bad for any use case, right? So what RisingWave does is that we actually help you to group inserts, updates, deletes into batches before writing into Iceberg. So in this case, you could imagine RisingWave as something like a caching layer before flushing the data into Iceberg. That's number one. And number two is that so basically we buffer the data. And number two is that we actually help you to compact the data. That's different from any other query engines, right? So any other systems, well, people will always say that, okay, I have integration with Iceberg. Let's say I have Kafka and my Kafka can directly write into Iceberg. So the next question I would like to ask is that, well, how do you manage these small files? Then nobody do, probably if you use Kafka, then MSK or something like that, AWS will tell you that, well, okay, you probably need to have a AWS EMR, right? Well, so basically, you probably need to have a Spark to compact the data. So that's pretty heavy, right? Well, because Spark is not efficient. Everyone knows that. I'm talking about open source Spark. Spark is not efficient, and it's definitely also very expensive if you want to do this kind of a compaction, Spark for this kind of compaction. So what we do is that more than just writing data into Iceberg, no matter whether it's in pipeline way or in the database way, we actually help you to compact the data into bigger files, right? Well, let's say that's 64 gigabytes, not gigabytes, what a megabyte, megabyte, right? We compile the data into merge the data, small files into larger ones in order to optimize the storage, and that's pretty unique in RisingWave. So there's yeah, okay. So yeah, thanks for definitely. Yeah, we have the window function support. Yeah. So that's definitely very unique to RisingWave. So which means that we actually do not really support for the we actually not only support for the RisingWave ingestion, so ingestion from Iceberg. We all sorry, syncing data into Iceberg. We also help you to compact the data. So right now, I mean, 2.5, you probably will see that it's under the premium feature set, but we will change that in 0.6 because we don't really want to. We are still testing it. Well, I mean, having our having some of the users testing that, but in 2.6, we will allow everyone to access to it. That's actually essentially 2 weeks later, probably 10 days later. Yeah. And for the compaction, we actually use the engine called, I mean, we actually build our own engine, and the engine was partially powered by Apache Data Fusion, and it's fully open source. And thanks to Cloudflare, and we actually work on this project along with Cloudflare guys they also have the Iceberg, and we essentially use the same compaction engine, and it's called Nimtable. Under Nimtable organization, it's called Iceberg compaction. Take a look, and you probably would like it. Yeah, it's all based on the compaction engine is based on the computation engine is based on Apache Data Fusion, which is good enough. So yeah, one thing I want to mention that people will ask me about, okay, whether I can directly use Data Fusion to query Iceberg. I do not have any comments on that part because I know that probably there are some limitations. I don't really want to spend too much time on this topic, but I want to mention that Data Fusion is definitely good enough for compaction, specifically for compaction. It's not about a query. Okay, don't get me wrong. Yeah, well, that's definitely there are more questions. So okay, so for I got probably 5 more questions. Well, I'm not sure whether I really have enough time to cover all these questions, right? But well, let me just try to answer some of them. With Iceberg, well, definitely the one question is that well, with Iceberg creation, you typically define the desired file size. Is it that right? Checking right to assuming data trickles in slowly during is there any actual compaction process running to optimize small files? Yes. The compaction process is running background, so you do not need to handle that. And we actually basically we're saying whether there are some small file issues, potential small file issues. We will actually basically do that check for you, and we do the compaction in the background. So, and then the other question is that what does RisingWave fit into the serving layer lakehouse? So basically, RisingWave fits into in the lakehouse use case. So we fit into we are more suitable for doing I think 3 things. Well, ingestion and compaction and the serving as a key value store. So I know that's what people will ask me about, okay, whether I can use RisingWave to replace Trino. I don't really think that's a good idea because I mean we are actually working on something on that part. But in 2.5, today's version, I would like to tell you that it's probably not a good idea to use RisingWave to replace Trino. Yeah, but it doesn't really mean that we're not support that functionality in 2.7 or 2.8. We're working on something. I'm just talking about today's version. It's definitely probably I would like to call it a SOTA solution, state-of-the-art solution to ingest the data into Iceberg and do doing compaction. If you look at any other engines in the market, data systems in the market, you will probably not find any system like RisingWave that can do compaction and the ingestion. even if you check for something like Snowflake, well, I mean, they probably could have something like they have their internal managed Iceberg, but there are a lot of limitations. But in RisingWave, we actually handle a lot of limitations with here. But yeah, back to our question. RisingWave, I don't really think that we should use RisingWave to replace Trino in 2.5. Do you balance latency, throughput, correctness to the end-to-end? I mean, latency, we are actually powering end-to-end latency. I'm talking about end-to-end latency. We have some use cases that is 10 millisecond latency, end-to-end trading, stock trading. End-to-end 10 milliseconds for latency, and it's highly optimized. Well, I mean, there is a product in RisingWave called RisingWave Ultra, and it's highly optimized for freshness, highly optimized for freshness. And so if you have some signal, if you're doing stock trading, right, or crypto trading, whatever trading it is, right, if you can't really care about the freshness, we just want to take actions within 10 milliseconds, take a look at our RisingWave Ultra, and essentially talk to us, and we will show you how to do that. Well, batch of data. So look, well, we probably have 20 minutes, and I want to finish all this for the slides first. Okay. So one thing I want to whenever we talk to people will say that okay, there are so many limitations in Iceberg, and I don't really want to. I'm not really sure about whether Iceberg is really what I want. So what kind of limitation they talk about? What I heard was that people will say that used to say that Iceberg doesn't really support the variant data type. A lot of people will say that it doesn't really support geometrics data type. I mean, these data types have already been supported in Iceberg v3. But one thing I want to highlight is that many, very few mainstream analytical query engines support acquiring equality delete, and that's probably one of the main reasons people give up Iceberg. So what is equality delete? So if you just look at Iceberg, you probably never hear people talk about this, right? Because it's pretty it's definitely technical details, but I have to say that as long as you start using Iceberg, you probably will immediately hit this issue. Why? I can give you one very simple example. That is, let's imagine that we want to ingest the data from MongoDB, MySQL, Postgres, right? I want to ingest their CDC into Iceberg. And you know that CDC it includes delete and update. In update, update can be translated as delete plus insert, right? And because we have the delete, if we write the delete into Iceberg, most likely your query engines won't support reading this delete, and which means that it cannot read a table. Imagine that I'm just ingesting ingest the Postgres CDC, right, and replicate the data into Iceberg table. And now you use Snowflake. Imagine that's where you are using Snowflake. You are using this Snowflake to query Iceberg table. You will immediately find that it's not queryable. Snowflake does not really support querying this table. It's pretty weird, right? Well, you can imagine that Postgres CDC is so popular, right? MongoDB CDC, everyone is using that. MySQL CDC, everyone is using that to replicate the data. But unfortunately, your downstreaming data systems or analytical systems don't really support equality delete. There are a lot of reasons, and I want to dive deeper into that part. So first of all, what is equality delete? Well, it's just about writing deletes, right? So what's the issue? Imagine that you have some data files, right? Well, you have some inserts, right? Well, insert two columns, two rows, delete one, and then insert another one. There are two types of deletes in Iceberg. One is called a position delete, and the other one is called equality delete. For equality delete, it means that essentially in the Iceberg files, what it will mention is that, okay, look, this is a delete, and the ID is equal to 176, and that's it. It's that's how it works. And and the file looks like this. So basically, Snowflake, Redshift, Databricks, or many other query engines. I think Triton probably could query this, but many other query engines could not read this file. They do not really have capability to read this file. It's pretty weird. And I know that some query engines are working on that, but and so far many query engines don't really support for querying equality delete. But what they support is querying position delete. So what is position delete? Position delete is that instead of telling me that the ID equal to 176, tell me the physical address. The physical address is row 3, right, in file X, and row 5 in file Y. This is the position delete. Basically tell the physical address. So that's why query engines could directly find the address, right? So you can like why don't we support this? Well, why many query engines don't really support equality delete? Because for equality delete, the query engines will essentially need to take more spend more time optimizing their queries. Because every time you again, in equality delete, we actually tell the query engines what the ID is, right? And the query engine actually have to do lookup to check, okay, where the data is. So that's very unfriendly to query engines. So that's why they do not really support this kind of operation, right? But equality delete is really good for CDC, and I also have to say that it's probably the only solution for DCC, because if you want to write the data, huge amount of data directly into Iceberg in a streaming way, and essentially just don't really want to check, okay, where the row is, right? You probably just want to directly write the ID into the small files, into the files, right? That's what you need to do. So yeah, and this is the state of art. You can see that for the Snowflake supports the internal Iceberg, and Databricks also support internal Icebergs. Redshift doesn't really support internal Iceberg, right? And if you check this column, the second column and the fourth column, you will immediately see that only Redshift claim to have the support for equality delete, but for Snowflake and Databricks, they do not really support this. So if the query engines don't really support this, then many people will just give up because it's not compatible with their query engine, right? So RisingWave is part of this. Well, I mean, we just want to make sure that you could work. I mean, you could still write into Iceberg, and the file should be readable by any query engine, no matter whether the query engine is no matter whether the query engine supports for equality delete or not. So how do we do that? We essentially so basically we want to RisingWave will write equality delete into Iceberg. And in the meanwhile, we'll do transformations directly to allow query engines to read the ingested data. How do we do that? There are 3 steps. The first one is that we actually want to we directly write a small CDC data into Iceberg. And then the second thing here we will do that we will do the merge. We will merge all the equality delete and remove all this equality delete from the file. And in this way, this is all done using the query RisingWave's compaction engine. Basically, RisingWave compact the data, compact a bunch of small files into a larger file, right? So that's what we could, So that's what we could remove all the equality deletes. And after merging the equality delete, we will expose this file to your query engines. So that no matter whether your query engine supports the equality deletes or not, you could use your query engine to query the Iceberg reading by RisingWave. So that's a magic in RisingWave. And I also want to make sure that RisingWave actually have its own log store to ensure that the deletes are exactly ones. so that will, I mean, even if let's say your upstream system, let's say Postgres crashed or RisingWave crashed or some other system crashed, no worries. RisingWave can guarantee that the delete will happen and only happen once. So that's what we can guarantee in RisingWave. So yeah, in this way, yeah, we know that well, if you use RisingWave to ingest the CDC data and into Iceberg, and you could well use any query engine you want to consume data from your Iceberg tables. So RisingWave is essentially a solid solution in the Iceberg ingestion world. Okay, I want to use the probably 3 minutes to mention a product called Nimtable. Nimtable is one thing we found that we found missing in the Iceberg world is the observability. So if you look at any other solutions in the market you will notice that it's more like a black box, and the only way to interact with Iceberg is from the CLI, right? Well, it's kind of like hacky. Well, and we actually observed this issue, and internally we built a tool called Nimtable to help us to debug Iceberg. And we actually nowadays, well, we actually open sourced it, and it's under Nimtable. You can search in GitHub. It's called a Nimtable, and we open sourced it, and it supports all kinds of functionalities. Like, okay, you could do table exploration. You could support multiple catalogs. You could directly interact, run interactive queries, right? And you could also even use AI to um, to get intelligent assistance for Iceberg table exploration. Well, actually, it's pretty useful, I have to say, because well, in many cases, people do not really write documentation, table documentation, and we found that AI is really good at writing AI documentation. So yeah, and we also support all these kind of like well, the system also compatible with observability too, also compatible with all different kinds of like REST catalogs, including REST catalog, Glue, AWS Glue, and some others, right? Okay. So this let's just summarize this for this webinar. I mean, RisingWave is definitely a solid solution for Iceberg ingestion and compaction. It offers two ways to interact with Iceberg: interacting as the source and sink, the pipeline way, right? Or interacting as the table. It actually lets users to ingest the CDC data into Iceberg and make it readable by any query engine, no matter where the query engine supports equality relates, right? And one thing I want to suggest you to use is the project called Nimtable. It's the observability tool, probably the only observability tool in the market that that is tailored for Iceberg users. Yeah. So yeah, let's go back to the question. I know that's what we have. Well, I have so many questions in there. So yeah, there's a question. Will the batch will that batching of data to write before reading to Iceberg affect any performance of material issue on Iceberg tables? I don't really think so. So for the for batching of data, it's actually good for the performance because you probably don't really want to write interact with S3 for so many times because every time it's no matter whether it's read or write, it's slow. It's slow. So you want to minimize the access to S3, interaction with S3 for sure. And there's another question. I'm using hosted Iceberg catalog with RisingWave. If I drop a table that's created with engine equal to Iceberg to recreate it after a schema evolution, will this action also remove the existing data? Um, you remove the existing data. So if you, it sounds like you adding a new column, creating a. So, okay, so you want to drop the table and ask me about okay whether it will remove the existing data. Yes, it will remove the existing data. I mean, so basically it's basically a compaction. Yes. So all the Iceberg changes available in community version? Yes. Yes. Actually, everything I mentioned today is available in 2.5. I think the only thing that's not available is the schema of solution. Yeah, we are still working on that part. And in I hope that's where it will be included in point 6. And for the compaction, right now it's under the premium set, but for in point 6, we probably will move it into the community version. Yeah, and the other question is that does RisingWave have its own query engine? For sure, yeah, we have our own query engine. So in the query engine, so basically we have so essentially two different query engines. One is the incremental computation query engine, which essentially powers the stream processing, stream ingestion, yeah, incremental material queue, everything like that. Well, it's super powerful. I think it's probably the best engine you can find in the market, incremental computation. And the second question, the second engine we have is the batch engine. The batch engine, we are actually improving that part, well, and so it's actually good enough. It's actually good enough to do something like ad hoc queries. Yeah, ad hoc, yeah, let's say point access. It's really good. Well, and I think we have already optimized the performance by a lot over the last 6 to 12 months. But in the future, we'll be focused on optimizing the query performance for the scans, for long-range scans, like think about the analytical queries. Yes, that's what we'll do. Okay. So I know that's what, yeah. Do you support for the Duck Lake on the roadmap? It's actually an interesting question. Yeah, we hear people talk about for Duck Lake, and hear a lot of people talk about Duck Lake. I remember that during the summer, everyone a lot of conversation. Duck Lake came out in many conversations, and right now we didn't really support Duck Lake, but definitely after this webinar, we'll definitely take a look, and to check whether it makes sense to support Duck Lake using RisingWave. Yeah, I think, well, technically, I don't really think there's any blocker. Yeah, but I probably need to, yeah, take a look for sure. Okay. Yeah, I know that's where there are probably still a bunch of questions, and so look for the yeah, because we only have 1 minute left. If you have any questions, feel free to join our join our Slack community, risingwave.com/Slack, and we could answer all different questions in the Slack community. Okay? Okay. All right. I think that's all for today's webinar. And thanks everyone for joining the webinar. And if you have any questions, well, feel free to ask, and we'll always be there. All right. Thank you.